So today we're going to create a game called Tic-Tac-Toe. It gives us a bit more of an exciting thing to do. And believe it or not, you already have all the knowledge you need to do this game. If you don't know what it is, simply go to Google, type in Tic-Tac-Toe, and you'll see it's effectively noughts and crosses. A player starts and selects an empty space and it gets filled with a cross. Then it's the next player's turn, which can select another part of the grid, and then it gets filled with a nought. And the winner is anyone that gets their symbol either horizontally in any 3 rows, vertically in any 3 rows, or in the 2 diagonals. And in fact, if you just go to Google and type Tic-Tac-Toe, you can play the game live here. So this is an example. There's a grid, a 3x3 grid. We click here, we get an X. And then the computer in this case puts a 0 here. So we'll try and go across here. We'll put one over here, and then it's blocked us. So we'll put one down here. It's blocked us there. Then we'll put one here to win diagonally. And you can see we've won diagonally there. So that's the principle of the game. If you need any more info, just Google what the game is. Now, to make this, instead of using Windows Forms like we did previously, we're going to use WPF. It's something we'll get into shortly in new videos, and it's really I mentioned it before, it's the modern UI, if you will. You shouldn't really be using Windows Forms anymore, they're massively outdated. So, start a new project. You want a WPF application with Visual C# at the end. And let's call this Tic-Tac-Toe. Now you'll still get this visual designer, and now instead of code behind that was in the Windows Forms projects where you had a CS file in the code behind, you've still got a code behind here, which looks similar, but this time the XAML file itself is effectively this code file. This visible part is simply Windows Visual Studio rendering this window for us, interpreting this file. So if you open this XAML file in Notepad, it's this content here, that's all it contains. This is the interpretation. Press F5 and let's see the window spin up. So you can see it's a basic Windows form for the most part. It looks exactly the same. But now we've got things like grids and much more easy to use UI. You've got your toolbox just as you did with the Windows Forms as well. And you can drag and drop things like a button, and there's a button. Press F5 and run, and you can see the buttons there. But we don't want to do this whole drag and dropping anymore, because the way modern applications work is no longer based on, you can see in this code here, it's set a hard-coded position by putting a margin from the top and the left. And things tend to be now, similar to websites, much more fluid. So instead of being fixed values and fixed sizes and fixed positions, they tend to be overall percentages, or a third of the available window space, things like that. So even though you can just use this toolbox at the side and drag and drop things on, we're going to do it entirely in code here, and we'll do videos shortly on how to do WPF. But for now, just follow along. I'll give you a brief overview of things. So the application's now got an app.xaml, which has your startup URI in this case, which is the startup page. So that means when the application starts, it looks for main window.xaml, which is here, and it runs this window, similar to the program.cs file did. And you can see the application itself is blank for the code behind, because the XAML file is specifying what to run in this case. So it'll basically run this window. When this window closes, the application finishes. So similar to Windows Forms in that respect. In this window, we have the width and height here. So let's change these to a more square value. Tic-Tac-Toe is a 3x3 grid that should be equal size. Let's press F5 and just make sure that's, there you go, it's like a square grid. We also don't want the user to be resizing this grid, so it doesn't go all distorted. So if you click at the end of this line and press enter to start a new line, and you just type resize mode, and you can see it selects it for you. Just press enter and it'll pop up instantly, and we select no resize, press enter again, press F5 to check that change out, And you can see now we can't resize this window. Let's change the title that says main window, which is here, title, and call it Tic-Tac-Toe. That's the window size done, the title done. And now this grid, a grid is, if you think of it as an Excel spreadsheet, you've got columns and rows. So for Tic-Tac-Toe, we need 3 columns, 3 rows. So let's go inside this grid. You can see everything's done with these lesser than and greater than symbols, similar to HTML if you've ever done websites. So inside the grid, you type grid dot column definitions, and you close with a right greater than bracket, and it will automatically add this closing bracket. So the way that these tags work, if you've never done HTML or XAML or XML, you put a less than sign, then the name, then a greater than sign, and then anything inside of that to the point where it then reaches the exact same thing but with a forward slash here is then content of this item. So everything inside this part is inside the grid. Similarly here, grid.column definitions, everything inside this area is part of the column definitions. So again, don't worry too much, we'll go more into depth about WPF in later tutorials, but for now I'll just give you really quick overviews of what we're doing. So now we're inside the grid column definitions, so we're going to define each column. So going across we need 3. So the first one, column definition, we simply specify width. So you type width, press enter, and it puts an equals and the quotation marks for you. Put an asterisk, so that's the star above the 8. And then you could close with a right angle bracket like that. Or if there's no content in this case, this is called an attribute on the element. There's nothing going inside of this. You don't have to retype all this. You can do a shortcut and simply put a forward slash. So this is now a self-contained item. It's exactly the same as doing that. It's just that because there's nothing here, there's no need for all of this. We can simply remove that and close it like that. Copy and paste this line 3 times, and you can see instantly we've got 3 columns. This star simply means a percentage value. So it's a percentage of the overall width, and because there's 3 of them, it equally then takes up a third of the space. If we remove one, you'll see that then it's taking up just half. So the star is simply a universal value that means, you know, count up the total number of stars in the whole definitions, and then it's a percentage of those. So that's the columns done. Copy and paste that whole column definitions. Simply change the word column for row. And we've got row definitions. Same inside, change these for row definitions. And change the word width for height. So now you can see here we've got a grid now of 3 columns, 3 rows, which is what we want. Now we need content inside these rows. So we're going to use buttons so they can be clickable, that act as the noughts and the crosses. So inside the grid itself, so these are inside the grid, and now after them is still inside the grid before we get here. So inside the grid we simply type what content we want inside the grid. So we open a new element again, type the word button, and we need to specify, well, first let's just close off the button, and you can see there a button's appeared, and by default it's gone to column 0, row 0. So you can change where this is in the grid by typing grid.column equals, say, 1. It's jumped to grid 1, column 1. You type grid.row, and you say column 1. It's gone to the center. So this is 0, this is 1, this is 2, 3, well, 0, 1 and 2 columns. Then this is row 1, column 0. So you get the idea. Columns across, rows down, starts at 0. So this is column, this entire column here is column 0, this is column 1, this is column 2. Rows across, this is column 0, row 0, this is row 1, this is row 2. So play around with these numbers if you're not sure what the values are, and you can see it moving around based on the values that you put in. So the first one wants to be at 0, 0, wants to be at the top. We also need a name for these buttons so that we can access them in code. So to do that, you type x:name, and then we'll call this button, and then we're going to use the column, and then an underscore, and then the row as sort of the naming convention. So button 0_0 is button in column 0, row 0. We then want to let's just give this some content so we can see a value. Let's put, say, an X in, and you can see there in the center we've got a letter X. Let's copy and paste that. Let's put a letter O, and you'll see that we've got the same name. We need to change this. We're going to move this to column 1, so we're going to go to here. So we need to change this to column 1. And now you can see we've got two buttons. We've got a button there and there. Copy again. You want the third one over. And there we go. We don't need the content here. We just want a few to show what they visibly look like when we style it to look nicer. So there's the first three. Copy and paste them. Now change the row here. So we're going to go to row 1. Same here. And you can soon see the benefit of making UI with code. Because now, instead of being forced on dragging and dropping elements and cutting and pasting things inside the UI, you can do it nice and easily in code, and you can really quickly name things. And if you remember the calculator app in the Windows Phone, we had to click every single button, then go to this little panel down here, then type a new name. Whereas in this code file, we can actually change the entire rows in one. So if you hold the Alt key on your keyboard and then click and drag, you can see we can actually select all of them in a row and change the rows in one go. So we can really easily change all three. Similar here, we've got the row 1. So let's copy and paste this now and do the final one, and you'll see what I mean. Hold the Alt, click and drag, change it to 2. Hold the Alt, click and drag, change it to 2. And now we've instantly copy and pasted and moved to the third grid. So if we press F5 to run this, you'll see we've now got a grid with clickable buttons, which is cool. We want to make this look a bit nicer. The whole point of WPF, well, not the whole point, but one major benefit of WPF is that it's really, really easy to style things. So let's change the style of these buttons to be a lot more like a tic-tac-toe game in appearance. So we want to, inside the window, because you'll see the window is here and it opens and it doesn't end till here. So the grid is inside the window. So if we go above the grid, so we're inside the window, we open and we type window.resources. And then inside the resources, we make a new style. And the target type, we want to be button. So we want to style any buttons that are in this window. So now to style the buttons, we want to change the background color to, say, white. We type the word setter because we want to set something. The property that we want to set is the background, and the value we want to set is white. And you can see there all the buttons have instantly updated to a white background. And again, you'll see very similar layouts. We've got the opening bracket, the closing bracket with the shorthand because there's nothing inside, and then we've got these two attributes. So the property is background, the value is white. Copy and paste this. We want to get rid of this border. Oh, well, we don't want to get rid of the border, we want to make it thinner so it looks like a nice thin grid. Type border and then go thickness, and let's make it half of a value. So again, this is more of an absolute value. It's not an absolute value, sorry, it's more of a relative value. It's not a pixel on the screen anymore because WPF responds to the DPI of the screen. So it's sort of a unitless value. You can change it to like 0.1 and you won't see it, 0.2, 0.3 you're just about to see it. So let's do 0.5, and let's just press F5 again to visibly see this. And you can see there we get a nice sort of probably 2 pixel border, but that's a nice looking border there. These letters are a little bit smaller, so let's make these letters a lot larger. So copy and paste this again. Font size, and let's go to something like say 70. There we go, that's nice. Now we've got big. Press F5 again. Got a nice big letter. So this is starting to come together nicely. What else do we want to do? So, to be honest, I think that's all we need to do in this UI. I think that is all we need. We can access these buttons based on the names we've given them. The grid, in fact, we'll need to access the grid when we're trying to find out where the buttons are positioned. So we need to give this grid a name, similar to the buttons, x:name. We'll just call this container. And now we can access this in the code. So let's jump straight to the code and let's make this game. So the code for this form, when the form spins up, is in this expanded drop down of the main window, and it's the saml.cs. Just get rid of all these grayed out usings because we're not using any of them. Just cleans up the class a little bit. This main window is the constructor, as you'll see. It's a public with no return type, and it's the name of the class, so therefore it's a constructor. So let's tidy this up and put it inside a region. Constructor. Oh. Let's give it a comment. And then when the window appears, we want to start a new game. So let's make a new function called new game. Move this outside of the region of the constructor. Just move it out for now. That's all we need to do when we start up, so we can minimize this region. Now for a new game, we'll need to make some variables first. So let's make a region for those. Private members. We want well, firstly we need to have a value that stores what the button is. So that can be a naught, a cross, or it can be unused. So right click over here, and we want to do add class. Let's call this mark type, as in the type of mark that's in that cell. So it's not going to be a class, it's going to be an enum, which we've used before, called mark type. The values are going to be free, naught, and cross. Comment this. So there we go, we've got a public enum of mark type that now can store free, naught, or cross. Simple enough. Now let's make, what we need to do now is store a list of values that holds a value for every button. So that's 9, there's 9 of them there. Now you could do a multi-dimensional array where you've got an array that's the first part of the array has then 3 inside, then 3 inside, then 3 inside. But let's keep it nice and simple. Let's just use a normal list, a normal array, and it's going to be 9 long. So let's just make an array for now called private. It's going to be the type mark type that we created, and it's an array. So just open and close the array. Let's call it results, and let's give it a comment. Then we'll also need to know whether it's player 1 or player 2's turn. So you want a private boolean of player 1 turn. And then finally we'll need to know if the game has ended. So if there's a winner or not, or there wasn't a winner. But basically we just want to know when the game ended. So And that's all the variables we should need. So let's collapse that region. Now back to the new game. So when a new game starts, we first want to create this results array. So let's make a new array. And as we mentioned, it's going to be 9 long. So it's going to be containing enough to hold all the results for every button. So we'll create a new blank array of 3 cells. So that's created the array. We now need to set the values for each one of these items. So we need to make sure it's the value of 3 and it doesn't just associate a different value to it. Now by default, because the mark type is 3 at the start here, the first item, this will be assigned 0, and by default an enum will be 0. So just doing this would actually set the results to, each result would be mark type 3. But if we ever then moved this 3 down to here, or explicitly give it a value such as this, then this code would stop working. So let's explicitly set each item. So we'll just use a 4, which we've used in one of the very early videos. So var I is 0, I is less than the result length I++. So basically go through every result, and then for that result set it to 3. So again, this, you've done this in I think it's the first or second video, so if you can't remember what for loops do, take a quick look at that video. We want to then make sure the player 1 is the current player. Now we need to also, because as we're playing through the game, these actual buttons are going to get changed. So you're going to have text, you're going to have content put in like this, and you're going to change things like the color of these text will make like blue and red so it looks nice. So at a new game we need to also make sure that we clear off all of the content so it's blank. So to do that, we need to access the grid firstly, which is we call container. So we type container.children, and you'll see that that says a list of all elements in the Windows control panel. So that basically means all these, list of all elements that are inside the grid, so all 9. So we just do container.children. Now we know they're all buttons in this case. We know everything inside this grid is a button. So let's cast all those children. So type cast, and if it's not there, hold Control and press dot, and it will say using link. It'll automatically add the namespace for link because that's where this cast is from. It's the link helper method, and that just basically converts this array of children, which is currently a UI element. So you see it's a UI element collection. We want to cast each element from a UI element directly to a button. Again, hold Control and dot, and it will say using Windows controls, system Windows controls. And then open and close the parentheses because that's a function. So we've got the container, we've got every child on that grid. We've cast all of them to what we know they are, which is buttons. So now we've got a list of buttons. Well, we haven't got a list of buttons, we've actually got a enumerable. So we need a list so that we can do well, you don't need a list, but a list means that we can use a nice link expression for each. So do toList and then dot for each. And again, we briefly used these in early videos. We won't go too much into depth about link, we'll do that in more advanced videos. But for now, I'm explaining what it's doing. So this makes it from an enumerable, which is basically like a list of an unknown size. It's a list that gets calculated each time you enumerate over. This fetches every button instantly, so we know this is now a solid concrete list. And then we do this for each. And inside here, we type button, that's just a name you make up, equals greater than, curly brackets, close curly brackets. And this little thing here is like a lambda expression. Again, don't worry too much about what it is, just look at how it's done and generally understand what we're doing here. So let's put a comment, iterate every button on the grid. So now inside this nice little one-line function, we got the container, we got the children, we converted them to buttons, we made that into a solid list, so then we can go for each to have a little function here now that runs for every button in that list. So it'll keep running this function over and over for the first button, then the second, then the third, then the fourth, all the way up to the 9th button. So now in this little loop that we've made, we can reset every button. So we can type button, and you can see it'll be the type button because we cast it here. We can do button.content, which, as you'll see on the XAML here, is this content. So that's how you set the text in the button, is with content. So we want the content to be an empty string. We want to clear off the content. You can actually press F5 at this point and make sure it clears off, because now what it should do is clear off these two pieces of content we typed in. Because at the start, when it gets created, it runs new game, then new game runs here, and then this effectively should go over every button and clear the content. So press F5. Oops, I think I typed something when I pressed F5 then. Press F5. Yep, so you can see it's cleared the text, which is what we wanted. So now at the start of every game, it will clear all the text. When somebody wins, we're going to highlight the backgrounds of the buttons to a colour, so it's nice and obvious who's won. So we also need to clear the background colour. For that we use brushes. I think it's called brushes. So press Control and dot, and there we go, it's found system Windows Media, which is correct, so press enter. Brushes.white. So we set a white background, which I think is it is by default because we made the style here. So we're effectively changing it back to default. And then also the foreground colour, which is the text colour. What we'll do is default the colour to blue, which we're going to use for the crosses. And then only at the point of when somebody clicks a cell and it changes to a note, we'll change that colour to green if it's a note. So by default everything will go blue, but obviously you won't see anything because they're not selected. And then when a note gets clicked, we'll change that to green. So by default, let's make the foreground of all of these into a blue brush. So change background, foreground and content to default values. So that will now create a new game. Oh, one more thing, we need to reset the variable, the game ended, I think we called it, game ended, to false. It's no longer finished. Make sure the game hasn't finished. So that will now reset the whole game. Ready. So all your variables are now initialized. Player 1 starts. Every cell's free. The buttons are all clear, and the game hasn't ended. So now we need to do something when these buttons are clicked. That's the next part of the game. So I believe you can still double click these, just like Windows Forms. And there we go, it's created a function for us. If we go back and look, all it did was added this click function here. So again, you wouldn't tend to use this so much anymore, you'd start typing directly. So you can see it's added a click attribute here by the name of button 00 click. Now because we don't really care, we don't need a different click event for every button. We can handle this in code and figure out what button was clicked. So let's get rid of the underscore 00, so it's just button underscore click. Let's change that name in the code to match. Go back, and then let's just copy and paste this click event to every button. And again, if you want to paste fast, you can hold Alt, click and drag down 3 lines and paste. And you can paste them in that way as well. So now every button's going to run this button click. So it's going to run this function. So let's first comment this new game. We forgot about that. So there's the new game done. Let's comment this. Handles a button click event. So now inside this button click, we need to firstly find out, well, I'll tell you what's going to happen. What we'll do, if we run this, you're going to click away, and you're going to say put an X here, then a naught here, then a cross here, then a naught here, and basically when the grid's full, that's the game ended. We'll say the game's ended. Or say there's 3 X's across here, 3 crosses. That's a winning game. So then we'll also flag it up as saying the game's ended. So then the game will look and be in its finished position, so the players can see who won. Now, what we'll do to start a new game is simply click again anywhere. That'll be like a nice way to reset the game. So what we'll do is, when we're clicking these buttons, we'll check if the game's ended. And if the game's ended, we'll start a new game. So if the game's ended, just do new game, and then return from this function. So there's sort of the new game logic. So when we set this to true and we click any button, it'll just restart the game. So that checks for that. Next, we need to actually get the button. So you can see here I commented. If you've not used event handlers much before, the sender is the thing that was clicked. So it's an object because it could be anything. An event handler needs to handle, any type of object. We know the sender of this click is always a button because here it's on a button and we've specified click. So we know this sender of object is a button. So let's first cast it to a type of button. And we've used these a few times before. And basically put in parentheses and then the type that you want it to be, and then the value after it. This is called an explicit cast, and this converts this object to a button. And this would crash if it wasn't possible. If we tried to change this to a label and press F5, you'll see this will crash the program. An invalid cast exception. You can't cast it, and if you hover over sender, you can see it's a button. Like we say, we know it's a button. So you've obviously got to cast to the correct type, but we know it's always going to be a button because it can only ever be clicked by a button. So we get the button. So now we know the button, but we don't know where this button is. We don't know whether it's on column 0, column 1, column 2. We don't know what row it's on. So to get that information, so let's make a variable called column. To get that, it's simply a case of you use grid.getColumn. And this expects a UI element, the element of that is contained within a grid. So we pass in the button. And this will now return the column that this button is on. Similarly for a row, as you guessed it, get row. So that gives us a column and a row. So let's just open Paint a moment and let's show you what this looks like. So I haven't used this in a while. So we've got a grid. Here's our grid. Not very well drawn, but you get the point. There's our grid. Now, column-wise, this is, as we mentioned before, column 1, column 2, column 3. Or, sorry, let's undo that if I can. Column 0, technically, because it works in starting with 0 and then 1. So it's column 0, 1 and 2. This is row 0, row 1, row 2. So say this part here is column 1, row 1. So this is a nice visual for you to see. Similarly, when we've got the column and the row, but when we made this piece of information here, the results, it's just a plain array. And it's 9 long, so it starts at 0, 1, 2, 3, 4, 5, 6, 7, 8. Now, how do we assign that to a column or a row? Simple way, draw another grid. So what we'll do is our results, so mResults, got caps lock on, mResults. This is going to be the 0 index, the first one. The second's going to be there. The third's there. The fourth's there. Fifth's there. I'm getting confused saying the fourth and fifth one. It's the number behind because it's a 0 index. And the 9th is there. So it's a 0 based index, it starts at 0. So the first item is going to be here, then here, then here, then here, then here, then here. So you can see column 0, row 0 is 0. Column 2, row 1 would be here, which is 5. So you can visibly use this if you want to try and understand, but just think of it as it goes across, then goes down in like a zigzag pattern. So it sort of goes across, down, like that. That's the way that the indexes work in the array. So we've got the column, we've got the row. We also now need the index, as we mentioned, so we can access the value in the array, which stores the results. So how do we convert a 0 of a column and a row number, or the value of a column and a row number, to this number? Well, the column is always 0, 1, or 2. Every time you go down a row, you effectively just need to add the previous 3 columns. So you need to add 3. So if you've got column 0, row 1, you need the number 3. So to do that, it's 0, so it's column plus the row times 3. So the row's 1 times 3 is 3, so that becomes 3. Column 1, row 1 would be 1 for the column, plus 1 times 3 is 3, so it'd be 4, which equals 4. Column 2, row 2, so it'd be column, which is 2, and row 2 times 3, so that'd be 6 there, plus 2, so it'd be 8. So you can see that works out. So the index is simply column plus row times 3. And the times 3 is because that's the number of columns we've got. So it'd be row times, the number of columns. That's how you get the index. Again, don't worry too much about that. That's more math than programming, but it's good to know that. Now, we can now get the result. So to get the result, or in this case, the current state of the button that we're under, the button that we've clicked, we can do result index, because this is going to hold the results. So this now gets the current state of that button, whether it's free, whether there's a cross on it, or whether there's a naught on it. So if the user goes and clicks, firstly, well, let's comment this code. Cast the sender to a button. Find the buttons in the array. So now, where were we? Yeah, so if the user clicks on, say you click and you put an X, you put a cross, and then the next player clicks on that same cell, you don't want that to be overridden by then a naught. If it's already got something in, then a click should do nothing. It's not a valid response. So to do that, we just check if the end results index, which is, you'll see this is where all the results are going to be stored. If that equals, well, in this case, you want to check it isn't free. So if that isn't equal to free, which means it's got to be a naught or a cross, because they're the only other 2 options, then we simply return this function. That's it, we stop doing anything because there's nothing more to do. So don't do anything if the already has a value in it. So that handles the clicking of a naught or a cross, we just ignore it. So that brings us now, if we get here, then we know the result is free. So now if the user's clicked there, based on whose player it is, so by default it's player 1's turn. If it's player 1's turn, the result should be a cross. If it's player 2's turn, it should be a naught. So set the cell value based on which player's turn it is. So that's going to be end results index, so get the value of this cell, and we set it, and we're going to do, I think it's called a tertiary operation, which is basically like an inline if statement. So you could do, if m player 1 is turn, then this equals mark type dot cross, else player 1's turn equals naught. Instead, what we can do to make this statement a lot more compact, you can do this way if you like, if you prefer to see it this way, but the other way is to do, and you can think of the if statement being on the right side here. So you can start the if statement by putting player 1's turn question mark. So you're sort of saying, is it player 1's turn question? If it is, the value is cross, and then the else, so if it isn't, you simply put a colon. So this is like a really compact if-else statement. So it's if this is true, question, this is what you do if it's true, else this is the false. So the result equals this if it's true, this if it's false. So if it's player 1, it's a cross. If it's player 2, it's a note. So that sets the result value up, and that's why checking this result here is, you know, correct, because basically every time we click a button, we update the result in this array to match. So that's the array updated with the value, the result. Now we visibly need to update the button itself. So do, as we saw before, button.content is the text itself. So the content equals, and then do the same statement. If it's player 1, it's an X. If it's player 2, it's a note. Set button text to the result. So that gives us the text, so you'll see the X or the 0. So if we run that now, you can actually see this working. You can see now when we click, you gain the X's. So we need to change the player's turn. So again, you can do if mPlayer1's turn, then mPlayer1 turn is false, else mPlayer1's turn equals true. Again, there's a much easier way to do this. So if you want to toggle a boolean, this is very specific for, you know, a true or false value. If you simply want to flip that value around, so if it's true you want it to be false, if it's false you want it to be true, you can use this little, what I like to call duck symbol. So because that looks like a duck to me, there's his eye, there's his beak, and that's how I remember this. So this is actually a bitwise operator. I won't go into detail on that. I'll do that in the next video, I believe. We'll go into like bitwise operators. But this basically, doing this statement, duck face true, as I like to think of it, inverts that value. So if it's true, it becomes false. If it's false, it becomes true. I'll explain why in the next video, but that's what that little line does there. So toggle the player's turns. Press F5 and let's check out what this does again. Now it should go, there we go, X naught, X naught, X naught, or cross naught. Now we mentioned we want the notes to be green. So as well as setting the button's text, we'll say change notes to green. So if player 1 turn, or in this case if it isn't, because player 2 is the note, so if it's not player 1's turn, then the button dot background equals background, foreground, we want the text color, equals brushes dot green. Cool. Get that in a minute. Press F5, let's take a look at that. Oh nice. Oh no, we don't want green, do we? We want red. That's the classical color. So it's usually when you see Tic-Tac-Toe, you'll see blue and red. So there we go, we've got a nice little, and you can see how nice this looks. It does look like a game. Whereas if you did this in Windows Forms, it would look nothing like this. You'd look like grey buttons, and to change the style would be much harder. The WPF is really easy to style and look really clean and, you know, flat. So now that's it. We can click away, and that's all good. It's working, and it's changing between players. That's perfectly fine. The only thing we've got to do now is actually check for a winner, so that we can then, for one, highlight the winner, or just highlight the whole thing as there is no winner, and then two, be able to actually reset the game by clicking again. This game ended. So now all that's left is check for a winner. Create that function, so control dot and enter creates the function, and checks if there is a winner of a 3-line straight. So as we mentioned before, a winner, go back to the paint, a winner can be here, 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 or here. So basically any combination of 3 values. We could do this in math with like a, you know, a single function, but that's going to get really complicated for such a a small grid, and for such a small game, we'll just do this manually. We'll literally check for this, then we'll check for this, then we'll check for this, this. So we'll have 10 checks, I think. 3, 6, 7, sorry, we'll have 8 checks. There's 8 possible ways to win. So we'll just type this time directly. So check for horizontal wins. So to do that, we know the results array contains the values, and here's the array. So we want to check if the results 0, 1 and 2 are the same value. So if they're a naught or a cross. If they are, that's a winning row. So to do that, you do if the results, and firstly you also need to check that the value isn't free, because you don't want, it's not winning if there's 3 blank rows in a row, so it's got to be a naught or a cross. So similarly, start with the first one. If the result isn't equal to 3, so that's your first check, and then we want to put this in brackets because we want this to be, well, you'll see why it needs to be in brackets. So long as the first one isn't free, and the first one, and then this is now a bitwise logic again. So I'll type it out and then I'll explain. So we check the first, the second, the third, and we check if it equals the first one. So this logic here, so let's move it out of this and so it's a little bit clearer. So this little logic here, what it's doing, it's checking the 0, 1 and 2, so this, this and this, so this line, and you see this single AND. This isn't checking if this and this and this is something. A double AND is the comparator, that checks if something's true. A single AND is a bitwise operator. So you can think of this as not necessarily like adding and subtracting, this is called bitwise. So it means that, let's say this result was true, a 0 or a 1. So let's say this was a true, and then you say true and this was false. The result of these two together, true and false, means false, because this and will only keep the values of these two together if both are the same. So what this is actually doing is saying if result 0 and result 1, so if they're the same and result 2, so this now means as 3 together, all these 3 ANDed together, if they're all the same, they'll still equal the first value, they'll equal the same thing. They don't actually add together and become more, they simply stay the same or get removed. So this little logic here, which again I'll go over in the next video, I'll do this whole logic. This does a check that if all 3 of these are the same, so if the first, the second and the third one equal the first one, this is basically a check that says all these 3 are the same value. So when you see this check, you won't understand it now, you will understand it in the next video, but this check is basically saying if this, this and this match. So that's what that check does. So what we'll say is if the results for 0, 1 and 2 are the same and they're not free because we've checked here, so it's a naught or a cross, you've now got a winner, so the game ends. And you also want to, we're going to highlight the winning blocks in green. So highlight winning cells in green. So this is going to be button 0, 0, background equals, and then instead of doing the background 0 equals green, and then on another line the next background is green, and another line the next background is green, you can just keep concatenating these together with an equals sign. So you can actually say button, and then this will be column 1 row 0 dot background equals, and then 2 background equals green. So this is done, this background equals this background equals this background, which equals green. So effectively this sets all 3 backgrounds to green, and it's the column, it's the row 0, so the top row, and it's 1, 2 and 3, so like 0, 1 and 2, so it's column 0, 1 and 2, row 0, so it's these 3. So if we run this code and we make a winner in this top, you can see there now this logic for the horizontal winners has found this winner. It's also set the game ended. So that means now when we click a cell, this should find out that the game's ended and start a new game. So we click anywhere now, it should basically clear everything off, which it does, which is good, and then you can carry on and play another game. So we're nearly done now. This is a working game. Now you'll see the other issue is what happens if you get to the end. So we also need to, we'll finish all these checks off for every possible win out of the 8. But after that check, we also need to make sure that we check for the complete ending of, there's no more cells left. We've got to check for that. So we need to do a check that if there isn't any results, so again, this is a link expression where this is the name we make, so the result equals, and if there aren't any that are free, so the results.any, this is a link expression, again we'll go through more in future videos on link, but this basically checks every single result. So we've tied this name, this can be anything, this could be the letter F if you want, makes no difference. So if then the logic here is if F is free, so this results.any will check if there's any values in the results that equal free, and then we're saying if there isn't, there's not here. So basically, if no results are free, so they're all taken up, we then know that they're all taken up. So the game's ended for one, because now there's no more moves, and we'll turn all cells orange to sort of indicate like everyone's lost type of situation. So to go through every cell, scroll back up to where we did that, which was here. Copy and paste that. And because we're only using one line, well, let's leave it there. Let's just do this. We've already commented above that we're turning the cells orange. So we just change the backgrounds to orange. So let's check this little logic. Check for no winner and full board. So let's basically fill every cell. And there we go, it's now figured out that there's no more moves left and nobody's won. And you click and you restart. So that's good. So now we've basically got the finished game. We just need to detect the remaining winners. So this checks for the horizontal wins. This is row 1. Row 1, or row 0 in this case. Let's just make a nice bit of spacing for copy and paste the whole thing. We want row 1, row 2. So row 1, we jump down, we're now doing 3, 4 and 5. So where there's a 0, you put a 3. So there's 3 times for that. And then this is 4 and then 5. And then the same here, you've jumped down a row. So this second value, the name is, in our naming convention, is the row. So we're now on row 1. Row 2, if you look here, is 6, 7 and 8. So that becomes 6, 6, 6, 7, 8. Game ends. This is row 2. And now we want to do a check for the vertical wins. So copy and paste that. This now becomes column 0. So now vertical wins 0, 3 and 6. So 0, 3, 6. 0, 0, 1, 0, 2. So that's column 0, copy and paste that. column 1. So column 1 is 1, 4, and 7. The columns moved over, so that's 1, 1, and 1. Column 2 is 2, 5, and 8. Oop. This is now column 2. And then finally check the diagonals. So let's copy and paste the description. And to be honest, this is starting to look a bit messy for a function. Let's just chuck these inside regions. Horizontal wins, we'll call this one. 1, 2, 3. And then again, it keeps it nice and organized. Vertical wins. No winners. And then finally, diagonal wins. Paste this in. Top left, bottom right. So for this, it's 0, 4, and 8. So 0, 0, 4, and 8. 0, 0 is the top. 1, 1 is the center. And 2, 2 is the bottom. And then it's top right to bottom left, which is 2, 4, and 6. And that is then 2, 0, 1, 1 again, and 0, 2. Press F5 to run that. Let's check. We should be able now to win. Well, effectively, that's the complete game. So let's do a diagonal win. And there you go. It's highlighted the win. Click to reset. Let's get. Oh, and something's gone wrong there. So this seems to think that we've got a win here for some reason. So let's just check that top right, bottom left. If I see here, I didn't change the 2 at the end of the 0. I missed this 2 here. So let's change that to 2. Let's try a diagonal win. Oops. Whoops. Okay, let's just kill the game. Try that again. And there we go, a diagonal win. Let's try this way. That's a win. Let's try this way. Win. Let's let notes win on the up. Win. So it looks like it's working. And that's really the completed game. That's how simple it is. Now there's a lot of little bits in here that we'll go over more. Like I say, this logic here, this bitwise, we'll go over in the next video, which is, like I say, effectively this just checks these 3 values are the same and that they aren't free. That's all you really need to know about this statement, is that that's what it's doing, and that's enough to, by the time you've read the next video, I'll watch the next video, you'll understand. Any issues, any comments, you know, feel free to leave comments. I'll happily reply to all of them and explain more, or do a follow-up video if anything's unclear. But in this nice short video, well, shortish, you've managed to completely make a nice looking tic-tac-toe game from scratch, and learned a little bit of WPF along the way. And this is, I think it's a really nice game. You could carry on and add a few extra things, like maybe some extra text that says, start a game, click anywhere to start, or things like that, or whatever you like. But that's up to you to try and take further. So I hope you enjoyed this video.